So in the second chapter, we are going to go through the working principle of Hillstone Firewall. In this chapter, I'm going to share with you the basic functions that we supported in Hillstone NG Firewall, and also the system architectures, the deployment mode, and how the data forwarded through the firewall. First of all, we just have a quick look for the NG Firewall features that's supported in Hillstone NG Firewall product. So basically, we support, as I mentioned, NG Firewall is totally different product comparing with the first generation and second generation firewall. NG Firewall can do deeper identification for applications and also users, and even for encrypted traffic, we can support the SSL decryption to identify the encrypted traffic and also block those malwares that transmitted through the encrypted traffic. And also basic firewall functions, as I mentioned, the routings, the policy, the netting, and also ALG functions for the multi-channel applications. And a basic attack defense, which is used to defend for the common attacks such as flooding, scanning, DOS attack, or ARP attack. IPS functions is one of the featured functions in NG Firewall, which can help the customer to protect their servers or their applications or operating systems. So this is the IPS, intrusion prevention system, which can defend those application layer attacks or intrusions. And also AV functions, which can help to detect any viruses that transfer through the firewall. And even for compressed virus, we can do the detections for the compressed files. And boolean filtering prevention, we also support to filter and defend the bootnet communication between your internal bootnet host and also the external servers. And URL control is used to do the web access control based on the priority URL category and also the scheduled URL control. QoS functions also supported in NG Firewall, which is used to do the bandwidth control for the specific users or applications. Or we can also do multi-layer nesting for fine-grained control of the traffic. And link load balancing and server load balancing also supported in NG Firewall. If you have multiple links, you can use the link load balancing to do the smart DNS detection and also routing the traffic through different link. And also we can do the health check for the link. And server load balancing, if you have multiple servers that you want to publish the service at the same time, we can also use the firewall to do the server load balancing. And VPN functions is also one of the integrated features in the NG Firewall. We can support the standard IPsec, SSL, and also L2TP, XAuth, etc. We also have our patent plug-and-play VPN. IPv6, we fully support the IPv6 protocol. So in this case, we can offer the pure IPv6 operating systems. The customer can use the Hillstone NG Firewall in the IPv6 environment. And we also support those transition technologies like DNS 6.4, NET 6.4 for dual stack between the IPv4 and IPv6. High availability also supported by our firewall. For the low-end firewall, we can support for both active passive and active active. And from the middle edge and high end, we can support the twin mode functions, which for active active data centers. And virtual system also one of the functions supported in the middle range and high end, which you can assign the resources for each of the VCs, and then you can use VCs to do some micro segmentations. We also have the models that can support for wireless control and also the 3G or 4G access. We also support the DLP, the light DLP functions, which we can use the device to filtering for some file transferred through the NG firewall, and also monitoring and statistics functions. So we support these logs, we support the statistics for the traffic, for all the threads, and also we support the report functions. So that are the major functions that we developed in the NG firewall. If you deploy the firewall in layer 2 environment, which is the frame forwarding mode, okay, we can also call the transparent mode. In this case, the firewall will learn the MAC address for both sides, the MAC address from both sides, okay, that sent through the ARP. So by default, the device will enable with the ARP learning and block learning to learn the source MAC. After the device learns the MAC address for both sides, we can help to forward the traffic through the MAC address table and also do the filtering and control in layer 2, and also provide the security protections. If you deploy the device in layer 3, which is the routing mode, so all the traffic, all the forwarding packets were determined by the destination IP or based on IP address. So you have to assign the IP addresses to all the interfaces. We support for both the static route and dynamic routes. And even for policy-based route, we can use the PBR to do the traffic steering for the specific applications. So in layer 3, the firewall are maintaining a routing table, to forward the traffic by the destination IP, And as I mentioned, the second generation, the stateful inspection firewall, the session concept is also used in the NG firewall, to establish the status communication between both sides and also maintain the session status through the 5-tuple. And the basic working principle for the firewall, as firewall is a security appliance, which we used to protect for the traffic. And also, we can use the firewall to do some fine-grained control. So the basic mechanism for the firewall, we will use the firewall to block or permit the traffic by analyzing the data packets through the DPI technology. And as long as the traffic matched with any existing policy rule, so the firewall will control the traffic according to the actions that configured in the firewall. Okay, and also as I mentioned, the zone is used to differentiate the network. And Stonewall's architecture, the basic system architecture of our NG firewall. So StoneOS is our operating system, which fully developed by Hillstone ourselves. It's a 64-bit operating system and support full parallel processing. So the StoneOS includes those major components, which are zones, as already mentioned before. Interfaces, it includes for both physical interface and logical interface. Virtual switch is also used, to support these functions in layer 2, and virtual router to support the routing functions in layer 3, and also policy, which is used to control for the access or for applications and users as well. Here, just give you guys some basic information how the web UI looks like in Hillstone NG firewall. So first of all will be the configuration page for the interface. So under the network tab, there is an interface. You can configure for both the hardware, the physical interface, and also the logical interfaces through the interface page. And zone, as I mentioned, we have some predefined zone. And you can also create the user-defined zone. The virtual switch, which is used to control the traffic that in layer 2. So you need to bind all those interface that work in layer 2 into the virtual switch, And also all the layer 2 zones need to be bound to the virtual switch. And the virtual router, we also have some predefined virtual router. So all the layer 3 zones must bound to the virtual router. Here is one of the diagram that can show you the relationship between the interface, the zone, virtual switch, or virtual router. Basically, all the interfaces you need to bind to the zone, to the security zone. As I mentioned, security zone is the concept or is the entity that we used to differentiate the network and also to control for the traffic flow. So first of all, you need to bind your interface into the zone. So if you deploy the device working in layer 2, you need to bind the interface into layer 2 zone. If the interface is working in layer 3, you need to bind to layer 3 zone. And also all the layer 2 zones need to be bound to a virtual switch. So vSwitch 1 is the default virtual switch. And for all the layer 3 zone, you need to bind to Trust VR, which is the default virtual router. If the device deployed in a hybrid environment, which is a mixed mode, some interfaces working layer 2 and some interface working layer 3. In this case, you need to use the virtual switch interface, which is the upstream interface between layer 2 and layer 3. The virtual switch interface will be assigned with the IP address. So all the traffic that through the layer 2 zone to the layer 3 zone can go through the virtual switch interface. Okay. So this is the relationship, for the virtual switch, virtual router, and the zone, as I mentioned previously. So all the layer 2 zone, we need to bound to virtual switch. Layer 3 zone, bound to virtual router. One interface can only belongs to one zone, but one zone you can have multiple interfaces. And all the layer 3 interfaces, because layer 3 is working in routing mode, you need to assign the IP address. Assign the IP address for the layer 3 interface. This diagram is also important for the technical guy to understand the overall packet flow, how the traffic forwarded through the Hillstone NG firewall. Let's have a look. So first of all, when we identify the incoming packets, first of all, we're going to identify the ingress interface to determine the source zone of the traffic, as you can see here. And then we will do the sanity check to determine the traffic, if the traffic is tampered during the transaction. If the attack defense functions enabled in the zone, AD is for attack defense. If the attack defense functions is enabled in the zone, we also go through the attack defense to check if any attacks that coming through. If yes, we will drop for the packet as long as exceed the threshold we set in the AD, in the attack defense functions. If normal, we will jump to next step, which is the session lookup. We will check the session table to see if there is any existing session created for this traffic. If yes, we will jump to this step. Which is second time application identification, because we already have the session created. So in this case, we don't need to go through all this checking. We just follow the same session to do the second time application identification to identify for the specific applications. And if ALG enabled, we can also check for the ALG profile for the multi-channel applications. If no any existing session matched, so that means this is a new traffic. Okay, so we will jump to the next step, which is the DNet, destination net. So we need to check if any DNet rule configured or matched for this packet to find the internal resources. After that, we will jump to the route lookup to see if any existing route for the traffic, so we can route the traffic. If no any route set or no matched route, we will definitely drop the packet. And the routings, as I mentioned before, we have several types of the routes, like policy-based routing, source interface-based routing, source-based routing, and destination routing, which is the default routing. So this is the matching sequence. So the PBR will be matched at first because there's policy-based control for the routing. And the destination-based routing is the default, which will be matched later after all this process. Okay, so after the routes mapped, okay, if we found existing route for the traffic, we will jump to next step, which is the Snet. We will check if there is any source netting for this traffic to translate the IP from private to public. And then we also need to check is the next hop is the virtual router. If yes, we also need to see if the VR number exceed the maximum number. If the next hop is not a virtual router, we will just go to the policy lookup, to check if there's any policy rules that configured to control for the specific traffic. If no any policy rule matched, so by default, the device will drop the packet. If matched with any policy rule, okay, we will jump to next step, which is the first-time application identification. If you enable the application identification in the security zone, as I mentioned, policy used to control the traffic that pass through the zones, the security zones, okay? So we will check for the first-time application identification to identify for the specific applications. After that, we will install the sessions, After the session installed, we will also do the second-time application identification. Just to make sure we can identify the application in more accurate. Okay. And then we will do the final action. We'll do the final action to forward the traffic through egress interface. So that is the overall packet flow in StoneOS. You need to take in mind for some of the key steps. Okay, in this case, it is also the way how we do the troubleshooting. So first of all, you need to understand what is the egress interface for the traffic. And also you need to know the source zone for the traffic. And then you need to check the DNet rule to see if there is any DNet required for this access. And after DNet, also routing lookup. You need to check the routing table to see if there are any existing route to forward the traffic. After the route, Snet. Okay, for any access from your internal to external internet, you should have the Snet to map the private IPs to the limited public IP. And after the net, also you need to check for policy. So policy is the one that finally control for the traffic. So that is the packet flow. And the working mode, actually I already mentioned a little bit during our previous slides. So first of all, if the device deployed in layer 3 routing mode, so you need to bind the layer 3 interface into layer 3 zone. Okay, in this case, we have 3 zones. The interface that connect to internet, we bind to untrust zone. And the interface that connect to your internal organizations, we use the trust zone. Interface connect to internal servers, we use the DMZ zone. If the firewall deployed in layer 2, we bind the interface that connect to your internal into the layer 2 trust, and the interface to internet, we bind to layer 2 untrust. And because of transparent mode, we don't need to assign any IP address for the layer 2 interfaces. And the firewall can also be deployed in a tapping zone to mirror the traffic from the switch, and then the firewall can do the detection, and analysis based on the mirrored traffic. Also the mix mode. As I mentioned before, the firewall can also working under the mix mode. So some interfaces that connect to layer 3 and some interfaces they are working in layer 2. For the interfaces that connect to layer 2, we need to bind to layer 2 zone. And also layer 2 interfaces do not have the IP address. So we need to create a virtual switch interface with the IP to set up the communication between layer 2 and layer 3. Okay. After we understand the data forwarding process, let's have a look at one example. So how the data forwarded. As you can see from this diagram, we have one internal user want to access to the web server in the internet. And we also have some internal servers. In this case, we bind the interfaces that connect to your internal users to the trust zone. The interface that connected to the web server, to the internet, we bind to untrusted zone. And the interface that connect to your internal servers, we bind to DMZ zone. Okay. If the internal user wants to access to this online server, okay, so first of all, we need to understand what kind of configurations we need to set in the firewall to allow this access. First of all, we need to configure for the interfaces. As I mentioned, for both of the interfaces that connect to your internal users and the interface connect to internet, you need to config. Second, we need to have the specific routings to route the traffic. We also need to have a net rule to translate your private IP to the limited public IP that assigned in your one interface. And finally, we need the policy. We need the policy to permit the traffic. So first of all, let's have a look those configurations we had been done for this kind of access. For the interface, as I mentioned, this is the interface that connect to your internal users. We bind the interface to trust zone and then assign the private IP to this interface. And for another interface, 0/4, we bind to zone untrust because this interface is the interface connect to internet. Okay, you can see this is the one interface. We assign a public IP at this one interface. So all your internal users access to internet will through this public IP. And routing table, we also add one default route. So all zeros, that means the default all destination route. Okay, so this is your gateway IP. This is your gateway IP. And we also need Snet to translate the private IP to public. So translate from any to any service. Okay, so through your one interface. So egress interface, which is 0/4. Okay, and translate the interface based on IP dynamic port mode if you have only one public IP. So we can also support the dynamic port mapping. To support multiple users can access to internet by sharing one public IP. And finally, we need to create a policy rule to allow the traffic from any to any zone, or in this case, we can do some specific control, which is from zone trust to zone untrust. And service we can leave as any, and action is permit. So after we configured, we also can go back to check. Okay, or we also can go back to check. Before you had done these configurations, okay, or if this is a new packet or new access, in the session table, you will have no any existing sessions available, okay, or no installed sessions for the new access, okay. And also we need to go back to check all those configurations step by step. As I mentioned, first of all, you need to check for DNet, but in this case, we don't need DNet because the internal users trying to access to internet. This case, we need Snet, not DNet. Okay, so we skip the DNet and then we jump to routing lookup to check the routing table to see if we already have a reachable route available for this access. As you can see here, we already had the default route. And after the routing, we also need to check all these zone or interfaces configurations. Make sure all the interface had been successfully bound to the specific zone, Okay, so 0/1 and 0/2 all bound to trust, and 0/4 untrust. Okay, connect to internet. And after that, after the routing, we also need to check the Snet. In this case, we definitely need a Snet. Okay, here's your source address and translate to the IP address that assigned to egress interface, which is the public IP. After the Snet, we will go to the policy lookup to see if we already configured any permit policy for the traffic. Okay. In this case, the second one will be the policy that permit the access from your source IP to the HTTP service permit. And after the policy permit the traffic, okay, we will also go back to check the session table. As you can see, the session already being installed. Okay, this is the session table. For bidirectional communication. So this is all those information I'm going to share in this chapter for the system architecture and also deployment mode of our Hillstone firewall, and also packet processing flow. These questions are quite important, okay, for you guys to understand the basic concept in this chapter. So you guys need to fully understand. So the interface, the zone, the virtual router, virtual switch, what is their relationship? Okay. So for the layer 2 interface, as I mentioned, we need to bind to layer 2 zone. For the layer 3 interface, we need to bind to layer 3 zone. Even the interfaces in the same zone, you also need to have the specific policy control for the traffic. For the interfaces that bind in layer 2 and some interfaces bind in layer 3, you need to create the virtual switching interface. And also one of the important part is the packet process flow, as I mentioned. So you need to understand the major step for the traffic filtering and the traffic forwarding. So first of all, you need to check the interface, the zone configurations, and also DNet. If no DNet, you will go to the routing lookup to see if there is any existing route for the packet. And after the routing, you need to check Snet. And after Snet, you need to check for policy route. Okay, so that is the basic packet processing flow and troubleshooting steps.